Hello everyone and welcome back. This is my third video for CTP1. This video will be covering the humidity sensor and the soil moisture sensor part of the project. It will also be covering other components required for simulation. DHT22 humidity sensor. The DHT22 humidity sensor can not only measure humidity but also temperature. In this project, I have used it only as a humidity sensor. Next, it uses a capacitive humidity sensor internally and a thermistor to measure the surrounding air and outputs a digital signal on the data pin, which means that no analog input pins are needed. It is fairly simple to use but requires careful timing to fetch data. Lastly, the only downside of this humidity sensor is that you can only get new data from it once every 2 seconds. Humidity sensor simulation. The components I have used for humidity sensor simulation are DHT22 humidity sensor and motor. Motor is used as a spray to obtain the measurements and control the conditions. Circuit simulation of humidity sensor. Humidity level is an ideal factor for plant growth. Now I will be showing the simulation of the humidity sensor. The level of humidity in this system is controlled by water spray. The ideal humidity for plants is around 50 to 60%. Therefore, I have used this range to code the program for humidity sensor. Humidity is measured by using the DHT22 sensor as shown. The sensor values can be changed manually in this simulation. If the humidity of the environment is below the defined level, the sprays are automatically turned on. And if the humidity level exceeds the defined level, the sprays are automatically turned off. The user will obtain the status of the water spray on regular intervals, communicating the status of the spray being on and off. This is the code for the simulation of humidity sensor. Now, coming back to the presentation, soil moisture sensor. First of all, let's start with how the soil moisture sensor works. The reading of the values by the soil moisture sensor is the metric measurement of the volume of water present in the soil at that particular measuring instant. The soil moisture sensor, unlike temperature sensor, humidity sensor, and light intensity sensor, is not available in Proteus due to limitations of Proteus. The moisture level in the sensor is detected by the U-shaped probes. When the water level is low, the analog voltage will be low in soil. The analog voltage will keep increasing as the conductivity between the electrodes in the soil changes. Hence, I have used a variable resistor which works with the same functionality as the soil moisture sensor. The components I have used for soil moisture sensor simulation are motor, L293D motor driver, and a variable resistor which acts as a soil moisture sensor. The motor represents the water pump and it is used when the soil conditions are lacking the quantity of water for plant growth. Circuit simulation for soil moisture sensor. Water supply is an essential component for plant growth. Now I will show the simulation which I have performed for this part of the project. Here I have used a water pump and a soil moisture sensor for detecting the soil moisture. The variable resistor is coded similar to a soil moisture sensor. When the moisture level in soil is low, the water pump turns on, and when the moisture level exceeds the limit, the water pump turns off. The input obtained from the analog sensor are captured by Arduino, following which a notification is sent to the owner with the status of the water pump indicating whether the motor is on or off. This is the code for the soil moisture sensor simulation. Now, coming back to the presentation, in the next video, I will be covering the type of light intensity sensor used. I will also be demonstrating the circuit of the light intensity sensor along with the proper functioning and simulation and the coding. These are the references I have used for this part of the project. Thank you for watching my video.